To solve a system of equations means to discover a value for its variables, in this example x and y, which solve both of the given equations at the same time. We can do this using a variety of different methods. In this example, we'll look at the use of the method of substitution. The method of substitution works by rearranging one of the given equations so as to solve it for one of its variables in terms of the other, and then substituting that expression into the other equation in place of that variable to reduce the number of variables from 2 down to 1 and give us an equation we can solve to determine the value of one of the variables and then use that value to determine the other. To get started, we'll single out one of these equations to solve for one of its variables in terms of the other. Here I'm going to single out the y in the first equation merely because it seems to be the simplest variable to isolate by itself in either of the two equations. Solving the first equation for y in terms of x requires only subtracting 2x on both sides of the equation, showing that y is equal to 1 minus 2x. Now that we know that y is equal to 1 minus 2x, we can replace y, anywhere we see it, with the expression 1 minus 2x, without changing the solution of our system of equations. So, we'll take that expression 1 minus 2x and substitute it into the second equation in place of the y. Because 1 minus 2x has multiple terms, it has two different additive terms, don't forget to surround your substitution with a set of parentheses. So in place of y in the second equation, I'll fill in an empty set of parentheses and then insert 1 minus 2x in that set of parentheses. The equation that we've obtained now involves only a single variable, x, and therefore we can use the techniques of solving equations that we know to solve this equation and determine the value that x should have. We'll start by simplifying the left-hand side of this equation, eliminating the parentheses using the distributive property. We'll combine the like terms, 4x plus 4x, into the single term, 4 plus 4, or 8x, and then unwrap the variable x by reversing the order of operations, adding 2 to both sides, followed by dividing both sides by 8, discovering the value x equals negative 1. So we know now what value x should take in the solution of this system of equations. But we're not done yet, because we also need to determine a value for y. Luckily, because we know that x has to be this specific number, negative 1, we can use that knowledge to discover what value y should take by plugging negative 1 back into any equation that we have that relates y to x. We could choose to use either of the two original equations, or, as I'm going to do, we can choose the equation that we got when we solved for y in terms of x. This choice will just save us a little bit of work, giving us now an arithmetic problem rather than an algebra problem to discover the value for y. Having substituted negative 1 in for x, we therefore know that y must be equal to 1 minus 2 times negative 1, and solving that equation to get the value for y gives us y equals 3. Therefore, the solution of this system of equations, the value of x and y, which satisfy both equations at the same time, are x equals negative 1 and y equals 3. So to solve a system of equations using the method of substitution, first, choose one of the original equations to solve for one of its variables in terms of the other. In principle, it doesn't matter which one you choose or which variable you choose to solve for, but the more you gain experience with these problems, the more that you might begin to choose the simplest substitution to make, as I did here, choosing to solve the first equation for y in terms of x because it involved the least amount of algebra. Substituting that expression into the other equation gives an equation with a single variable that we can solve for one variable, and then substitute that value back into any of the original equations to discover the value for the other.